In this section, what we're going to do is create two implementations of an autocomplete box. The first implementation is going to use just straight up jQuery. It's going to be written how you would normally go about writing such a piece of functionality. Then I'm going to turn around and I'm going to implement the same thing using reactive extensions. So we're going to get a little bit of an introduction to reactive extensions and kind of get an idea of how to work with it and how to use it in a real-world scenario. But this video is going to be all about creating our basic naive implementation of an autocomplete text box and talking about all the potential problems you might run into. So let's go ahead and get started. Over here, I have a command line window, two command line windows. Both are open up to the playground, and then I have, of course, the playground in Visual Studio Code. I'm going to go ahead and start my gulp watch scripts task so we can build our scripts as they get written. And make sure that that is going to run. And it looks like we're good to go. And then on the other command line, I'm going to open up, I'm going to do a live dash, or I could just cd into public and then do live dash server. So again, live dash server is simply our live server that we're going to use to serve out our HTML and JavaScript files. Then I'm going to come over here to example 00. We're going to start off by building our HTML. So I'm going to take this, I'm going to copy and paste it, and I'm going to rename it to example 01 basic AC for autocomplete. And for this, we can change this header to autocomplete. For our script, we're going to do build example 01 basic AC, because that's going to be the name of the client JavaScript file that we're going to create. As far as the HTML we need for this example, we do need a form element, and the action is irrelevant. And then I'm going to open up an input with a type of text and an ID of, let's say a title. Let's say we're searching some sort of database based off title, and as we type in, we want those results to appear. So of course we need to do a UL, and I'm going to give it an ID of results. So we have a form, an input, and a UL, and we have an ID on both the input and the UL, so we can grab that from JavaScript. Okay, so that's the HTML page. You can pause the video if you want, because this is probably going to be the last time we're going to be looking at it. So we do need to go ahead and create a JavaScript file called example01 basicac.js. And of course, we create it in our source client folder. Remember, that folder, everything put in here is going to compile into our build folder. So I'm going to right-click New File, paste in that name, and hit Enter. And I'll go ahead and I'll alert out hello. And I see it did build. So if I jump over here into my light server and refresh, and I can click on example01 basicac, and we get our hello. Okay, so that is our autocomplete so far. Super, super exciting. Well, it doesn't really do anything, so what exactly is it that we want it to do? Well, first of all, we do need to go ahead and grab a reference to our UL that doesn't have any items in it. Remember, we still have that UL there, but it's empty. Probably should get this open as well. So if we look here, we have our form and our UL. So we want to get a reference to our input and our UL. So I'm going to say, I'm first going to import jQuery. So I'm going to import money from jQuery. So again, if you're not familiar with the new import syntax, we simply say import, and then we can pass in a list of things to import, or we can import the whole module, and then we say from, and then the module name. So that's equivalent to var money equals required jQuery. And of course, for people not familiar with Browserify, what that did is Browserify located the jQuery module within my node modules folder. Remember, we installed that earlier. And it went ahead and it stuck it in our built output. So now jQuery is available on the page, all by simply doing import money from jQuery. Super awesome stuff. So let's go ahead and grab references to our elements. So I'm going to say money title equals pound title, and I'm going to say const money results equals money pound results. So I do want to point out that my convention is always to prefix all variables that point to a jQuery element with money. All right, so before we get started attaching on to title and providing our autocomplete implementation, I'm going to create kind of a dummy function. I'll separate it out here, and I'll do library. And I'll create this kind of dummy function that simply returns a promise called get items, and then it'll search by title. And it's simply going to say console log, and we'll say querying title, and then I'm going to return a promise. So I'm going to say return new promise, resolve reject, goes into blah. If you're not familiar with promises, they simply represent asynchronous operations. You pass in a function into the promise constructor that takes in a resolve function and a reject function. These are your callbacks. You call the resolve once you've successfully completed the asynchronous operation, and you call reject when you want to cause an error. So for this, I'm simply going to say window.setTimeout, and then I'm going to pass in resolve. And for this, I'm going to, for resolve, you pass in the data you want to pass back into whoever invoked the promise. So we're going to pass in an array of items that match the title. And I'll start off by doing title, and then I'll say item 2, and then I'll say another, and I'll do math random. So I'm just passing in an array of the title, a constant item, and then another item that has the math random. Of course, this is simulating a network call, a call over the network to some sort of API location that might query a database. And then, of course, we will put in, for the timeout, I'll do 150, or how about 500 plus math.random times 200. So basically we're saying at least take 500 milliseconds to perform this request, but go ahead and take anywhere from 500 to potentially 700 milliseconds to complete. And this is going to play in, this simulates the fact that you can make 2 queries to an API, but the one that you made first might actually complete last, and that sort of simulates it. And we're going to see this behavior in our autocomplete, and it's going to bring up the kinds of problems that we're going to resolve with reactive extensions. So, okay, so now we do the query. Now we have our magical get items function that goes off and queries a magical database. Not really, but you can pretend that it does. So how would we actually go about making this autocomplete box work? Well, a good thing to start off with is you might say, okay, so title on key up E, right? So key up, so we're hooking into the key up event. So every time the user presses a button inside that text box, we'll get this event fired. And you might go ahead and say const value equals e target value. Remember, the target property of an event is the element that was that raised that event, and value reaches into the input box and gets the value. Then we might say something like get items for value. I might want to call this title, actually. I like title better. And we'll say get items title, and then since get items returns a promise, and Visual Studio Code recognizes that it returns a promise, so I get a awesome little autocomplete here, I'm going to call the then function on the promise, and I'll say then items goes into blah. So this is kind of how promises work. I can say get items, it'll go off, perform that asynchronous operation, and then once it's done, it'll invoke this callback that I passed into this then method. And then we might say results.empty, and then we might say results.append, and for this we want to go ahead and create an li for every single one of these items. So I can clean up this code a little bit by saying const items equals items.map, item goes into money li dot text item, and then I can simply say results append items. We could do this on the same line, but I'm trying to keep my my width of the text editor here as low as possible for you guys. So basically, we just go ahead and get the items array that was passed into this resolve, and we map it to individual HTML elements, and we append it to the results. And you might think we're done here. So I can go ahead and say hello world, but you'll notice some interesting behaviors, and it might be more apparent if I took this times 200 and maybe launched it into, turned it into 600 here. And then I say hello world, and come on, do the thing. Maybe might want to bump this to a second. You'll see where I'm going with this in a moment here. If I type in hello world really quickly, look at the fact that the last query that got executed was hello WR. Why is that? Well, that query took longer than the other queries and ended up as last, and that's the results that we got. There's a couple other issues. For example, watch the console here. I'm going to clear it out for you guys. Watch what happens when I press the up button. So it says querying hello world. So we're performing these queries, but the input isn't changing, so that's another issue. Finally, the last big issue with this is if I really type in hello world, blah, whatever, notice how it performs a query for every single result. So we're going to go through each one of these problems one by one, and we're going to solve it in this sort of naive sort of implementation here, and kind of start to see how messy this kind of code can get. The first thing I want to fix, or the easiest thing to fix, is when I press this up and down arrow, I don't want to requery. See how that number here is going up every time I hit my arrow keys? That's easy to fix. I can go ahead and before the key up, I can say let last query equals null. And then right here, after we get the title out, I can say if title equals last query, then simply go ahead and return. Otherwise, say last query equals title. So then we've solved that problem. I can go ahead and type in a query, and I can hit up and down and all my control keys as much as I want. And notice how we're not re-querying the data source because we're short-circuiting on if it's the same value as it was before. The next thing I want to do is fix it so it'll only query after 200 milliseconds after the last key up. So how would we do that? Well, a naive way to do this would be to use the setTimeout method. So I'm going to create a variable up here above key up, and it's going to be called timeout, or how about last timeout? I'm going to initialize it to null. And then what I'm going to do is down here, after we do last query equals title, I'm going to say if last timeout, then window.clearTimeout last timeout. And then, so this will say, if we have a timeout going already, go ahead and clear it if a new request came in. Now, the last thing to do is wrap our get items in a window set timeout. So I simply have to say last timeout equals window.setTimeout, and I have my function, and then I have my value here, and I'm going to put 500 milliseconds. So we're only going to perform the query if the user has stopped typing for 500 milliseconds. Now I have to take all this code that actually gets the items, and I'm going to cut it, and I'm going to paste it right here into our window.setTimeout. So now we're only performing this query after 500 milliseconds after the last key up. So let's go ahead and see if that works. I can come in here and really quickly type in hello space, and check that out. We only got one query, hello. And we can do WOR and so on. Now, we still have the issue where we might get a race condition. So we fixed the issue with the throttling, and already the code is starting to balloon up in size. And you guys might be used to, you know, massive levels of indentation, all that fun stuff. Obviously, we could maybe turn this into its own method. We could do some work to clean this code up, but the code would become larger to clean it up and make it more readable. But let's go ahead and fix the last issue where a result can come in before the or after the result was already another result already came in, and that's a huge issue. Maybe if I take this random and bump it up to 2 seconds, it would still be obvious how that works here. So hello, and then world, and so on. Okay, it is becoming very difficult to reproduce the bug, but the bug is still there. Let's say random by 5 seconds. W, A, F. So we have W, and then we get A, and then we get F. That still does demonstrate the issue, though, because our results are still coming in before the final result did. So we're getting this kind of... I'm sure you guys have seen autocomplete boxes like that, where you start typing in, and it correctly orders everything, and it debounces everything properly, but as you come in, as you start typing, you see the autocomplete box just start flashing and going crazy, where all these other queries are coming in at the same time. And we want to prevent that. And the way we're going to prevent that is to give each one of these queries its own ID, and we'll only present the results if the ID matches the ID of the last query. So I'm going to say let next query ID equals 0. And then down here, before the window set timeout, this is important, it has to be before the window set timeout, I'm going to say let our query ID equals ++ next query ID. And then what I'm going to do, right here on my then, so remember, this is where, on this get items then, maybe we can clean up the code a little bit by doing it like that. That's when the request has completed. I'm going to say, if our query ID does not equal next query ID, then return. So now we're going to throw away any results that come in that are stale, that they no longer represent what the user has typed into the text box. So now I can say HWOR, whatever, and you notice it's blank until we get the HWOR query. So we only see the results of what's typed into the autocomplete box. And that's a very important aspect to the user experience of an autocomplete box. But now let's take a look at this code. Yeah, it doesn't look so long, but we have multiple levels of indentation. We have a lot of global state that we're manipulating. Maybe not global across the whole page, because this is a JavaScript module, but global across this module. And that's problematic. We have to keep track of our last query, our last timeout, our next query ID, and all that fun stuff. And we have code that really isn't representative of what we're trying to do. This code doesn't represent what we're trying to accomplish. It's just instructions to the computer to kind of do what we need it to do. And as a result, it's very verbose, lots of indentation and mutation of global state. In the next video, we're going to see how to accomplish all of these things in ridiculously few lines of code. So yeah, this is, again, this is the kind of code you might have written in the past, maybe not for an autocomplete box, maybe for something else. This is a very common pattern in writing web applications. So in the next video, we're going to see how to clean that up substantially. And we'll see you guys then.